Hi, my name is Tina Riordan, and we are going to be discussing distribution, specifically normality and skewness. So the shape of the distribution provides information about the central tendency and the variability of measurements. So when looking at the shape of a distribution, one may consider skewness, which is the measure of asymmetry of a distribution of a variable. So to ascertain whether or not a distribution is skewed, one should understand the relationship of three different things. One being the mean or the fulcrum or the average of the scores. Two being the median or the middle score when the numbers are placed in order. And lastly, the mode, which is the frequently most occurring score within the data set. But it's also important to note that with the mode, there may only be, one mode, there could be no modes. If there's two modes, it's bimodal. If it's many modes, that would be considered multimodal. So what is a normal distribution? Normal distribution is represented with a normal curve that showcases this perfectly symmetrical distribution. This is also going to be known as a bell-shaped curve. And the mean is going to be represented by 0 with a standard deviation of 1. And the total area that lies underneath that curve is going to consist of 100% of the data set. So these standard deviations are going to help measure the variation within this distribution. So within this, you can see that 34% of the data is going to fall between the mean and one standard deviation above that. 68 is going to fall one standard deviation above and below the mean, followed by 95% falling 2 above and below. And lastly, 99% of the scores are going to fall between 3 standard deviations above and below the mean. Also, it's important to note that within the symmetrical distribution, the values of the mean, median, mode are going to be equal to each other. And thus, that's going to result in a skewness of 0. But what happens when a distribution is not so symmetrical? So when a variable's distribution is not symmetrical, this is when it's going to be considered to be skewed. And this means that the mean is not going to be in the center of the distribution. So when you're looking at the distribution, please pay attention to the tail itself of the distribution. So in this example right here, if the tail is longer on the right side, it's going to be considered positively skewed because the mode is less than the median, which is less than the mean. However, if the tail is long on the left side, it's going to be considered negatively skewed because the mean is less than both the median and the mode. So when looking at an important calculation to utilize when you're looking at the significance is the skewness ratio, which is the skewness statistic divided by the standard error of the skewness. So for example, if we're looking at an SPSS data set, the skewness ratio would be the negative 2.80 divided by the 0.393 equaling negative 0.712. And it's important to note that there's going to have to be a criteria that's going to be met. So since the skewness ratio falls between, as pictured here, the negative 1.96 to positive 1.96, it fits the criteria for a normal distribution where the mean, mode, and median are going to be very close to each other, representing a bell-shaped curve. So visually, if we were looking at data set, I am an athletic trainer, so I'm going to keep it athletic training related. So if we were looking at a distribution of athletic trainers within a study, and we were looking at their ages, and it visually presented as this, we're going to see that there's a symmetrical distribution where there's going to be no skew. So you'll find within this data set that the mean is equal to the median, which is going to be equal to the mode within that center of the distribution. However, let's say we were looking at another variable, and let's say we wanted to look at compassion fatigue during the preseason. So when, things are a little bit more calm, burnout's really not experienced, and no secondary trauma is going to be seen as much as it is throughout the season. So if we were looking at that, we'll take a look at athletic trainers during preseason, and then we get this type of compassion fatigue result. So we're going to see that within this data set visually that the mean is greater than the median, which is greater than the mode. And as you can see, the tail is going to be on the right side, making it positively skewed. However, let's run this again later on in the year when things get a little bit more hectic. So we're going to go ahead and run those same compassion fatigue scores. However, you can see now that the tail is on the left. And you can also see that the mean is less than the median, which is less than the mode. And visually, you're going to be able to see that this is going to be a negatively skewed distribution. So kind of looking at all of these will help you analyze data and talk about the direction of the skewness. And that can be related with z-scores, outliers, and many other things. So this is useful in describing our data sets and using it in the world of statistics.